Hi, my name is Giada Pistilli, and today I'm going to present our paper, Stronger Together, on the articulation of ethical charters, legal tools, and technical documentation in ML. This is a joint work done with Carlos Muñoz Ferrandis, Margaret Mitchell, and Yacine Jernite. So several tools to guide AI development and deployment exist today in different disciplines. And among them, we can name ethical frameworks, licenses, and technical documentation, such as, for example, model and data cards. Our argument is to say that there are really interesting interactions and interdependencies that exist between philosophy, and so namely ethics, law, and computer science. If we dive in a bit in their theoretical background, we can talk about different notions of compliance for each discipline. So, for instance, when it comes to ethical compliance, it involves the detailed articulation of principles and values that are usually enshrined in an ethical charter. So this articulation catalyzes direct moral responsibility on the part of the same individuals who drafted and signed the ethical charter. Concerning legal compliance, it involves ensuring that AI systems comply with relevant laws and regulations. It's usually described as being a social process focused on fostering cooperation between, for instance, businesses and governments. Finally, when it comes to technical compliance, it involves ensuring that AI systems meet technical standards and specifications. And so it ensures the AI systems are reliable, safe, and explainable. If we try to summarize those three notions of compliance in a question, we can see how the role of ethics, law, and computer science are already interdependent. For instance, concerning ethical compliance, it tries to answer the question, how ought this technology be used? Concerning legal compliance, it tries to answer the question, how shall this technology be used? And concerning the technical compliance, it tries to answer the question, how can this technology be used? If we try to see how this articulation between the three disciplines work together in theory, we can see in the figure how there are different movements and interactions, especially coming from the normative side of it. So for instance, the normative compliance, and so ethical compliance, it expresses the values that are usually drafted in an ethical charter, defining the AI system priorities and especially the project behind it. And so this normative component influences both the prescriptive and descriptive aspects of the AI system in question. So when it comes to the prescriptive aspect of it, it pertains to what uses of an ML artifact should be allowed or prohibited based on the values that are expressed in the ethical charter. Finally, the descriptive part of it, it relates to reporting the capabilities and possible failures of an ML artifact. And so it includes an extensive documentation which informs what potential harms or rights violation need to be addressed in licenses and regulations. And so we can already see here all the movements that are coming, especially from the normative part of it, and so from the values that are expressed in the ethical charter. If we try to give a practical example, we can talk about the Big Science project, where the three disciplines worked together. What's Big Science? So it was an open science project which aimed to develop a very large multilingual language model called Bloom and its multilingual dataset Roots. So it was a large-scale collaborative effort that saw the involvement of over 1,000 researchers coming from all over the world, speaking all different kinds of languages. And it was also a wide range of different disciplines interacting together and scrutinizing different aspects of the project. And so we saw those three different notions of compliance interact with each other, namely between the Big Science Ethical Charter, its license, Responsible AI License or RAI license, and Bloom's Model Card. How so? So through a consensus-based process, the Big Science collaborators described and outlined the project's intrinsic values. And so coming from those same values, they informed the development of the RAI appendix, reuse restrictions, and Bloom's Model Card. So to go a bit deeper on this example, we can try to talk about some of the values that have been put into operation in the Big Science workshop. For instance, reproducibility. So it has been described and defined in the Big Science Ethical Charter. It has been then expressed through an open license, so namely the RAI license. And finally, it has been operationalized by the technical documentation, since Bloom's Model Card tries to answer the questions related to its reproducibility, what kind of hardware it's needed to reproduce the same experiments and the same results. Or if we want to talk about another example, we can take the value of multilingualism. And so we can see multilingualism as being a value to lay the foundation of the project, but also it can also be seen as a technical feature in order to make multilingualism happen. And so we can say that AI is definitely an interdisciplinary field, and it has also interdependent notions. And so when it comes to a specific ML artifact or full AI system development and deployment, we need broader collaboration and interdisciplinary initiatives. Some of the limitations of our arguments are, for example, the fact that it's really hard to be proactive instead of reactive. And sometimes it can be hard to balance competing values and priorities. And so both of them are usually dependent of the fact that AI, as we all know, goes really fast and has a really quick pace. So in conclusion, all interdisciplinary AI fields need to work jointly on developing practical tools and methods for integrating, among other things, ethical, legal, and technical compliance into AI development processes. And so ethical, legal, and technical compliance can be considered in isolation in this context, but we argue that they're definitely stronger together. Thank you.